Hello everyone. Today we are doing a great question. This is question based on number theory basically. So this the question says determine all integral solutions of a square plus b square plus c square equals to a square b square. So yes, a square plus b square plus c square equal a square b square. So we are at the all integral solutions of this question, this equation. So this has a great way of approaching this question. This is this type of question is also known as infinite descent. Infinite descent. So it has a great way of solving it. So we have to find the all integral values of a square plus b square plus c square equal to ab whole square. Okay. So first, what we're about to do is make case 1. So first case is we know that the square of any number is congruent to 0 or 1 mod 4. Suppose n square is a number, the square of any integer, then it is congruent to 0 or 1 mod 4. So basically it leaves the same remainder, the n square, when divided by 4. It leaves the same remainder as 0 and 1 when divided by 4. So that means that when n square by 4 is divided, we get 0 or 1 as remainder. So I'm going to introduce the topic congruence now, if it is not clear. So two numbers a and b are said to be congruent to each other, a congruent b, if they leave the same remainder, if they leave same remainder when divided by n. So a is said to be congruent to b when they leave the same remainder when divided by n. A is congruent to b mod n. So A is congruent to b mod n when it leaves the same remainder when divided by b. So by this we can just check, or we just know it, like the square of any number, it is square of any number is congruent to 0 or 1 mod 4. So therefore we have in the question was a square plus b square plus c square equal a square b square, right? So this is the question. Put it here. So since n square is congruent to 0 or 1 mod 4, we can write a square is also congruent to 0 or 1 mod 4. So since this is case 1, we are taking a square is congruent to 1 mod 4. So when a square is congruent to 1 mod 4, we can write it as a square plus b square plus c square congruent to a square b square mod 4. Since both are same, you can just see it. So now a square we can to take out from both sides. So we have b square plus c square congruent to plus 1 plus b square c square, since we are taking out from both. We have congruent to b square mod 4. So we got c square congruent to minus 1 mod 4. So this was what we got, but we know any square is congruent to 0 or 1 mod 4. But since we got c square is congruent to minus 1 mod 4, so this is rejected, and this is not uh, used in as a like a solution. So now what we did this in this step is, if you missed it, is we have the equation a square plus b square plus c square is equal to a square b square. So what we did is we just put mod both sides. Yeah, you can do that. So a square plus b square plus c square we have here. Then we put a square b square. We put mod 4 both sides. Maybe to help us with the solution, we put mod 4 both sides, which is basic manipulation with congruences. So now we got that c square case. It is now rejected. Therefore, case 1 is completely rejected. Case 1 is rejected. Now we have case 2. In first case, we took a square congruent to 1 mod 4. So this time we are taking 0 mod 4. So remember this result, n square congruent to 0 or 1 mod 4. Okay, so now we took a square congruent to 0 mod 4. Therefore, again, in the same equation, a square plus b square plus c square, a square b square mod 4, we took mod 4 both sides in the original equation. Then since a square is congruent to 0 mod 4, so we can write this as 0. Then this will be b square plus c square congruent to this is 0, then it will be 0 mod 4. Okay, therefore from this we can conclude b square congruent to c square mod 4, which means that if two squares are congruent to mod 4, we can see that a b c is even. Why, you may ask? Because it leaves no remainder. There is no remainder when b square is divided by 4 and c square is divided by 4. There is no remainder since it's a square and both squares are congruent. So we got ABC is even. Now we can remember that result. Therefore, if ABC is even, so let us now look. If ABC is even, then we can put A is equal to 2A1, B is equal to 2A2, C is equal to 2A3. A and B and C and A, B, C all are even multiples of something. So we put A is equal to 2A1, B is equal to 2A2, and C is equal to 2A3. Therefore, now we need to put these values in the original equation. So original equation was, which is now a square plus b square plus c square equal a square b square, 4a1 square plus 4b1 square plus 4c1 square equal to um, equals to 16 a1 square b1 square. So we can divide by 4 on both sides and we will get a square a1 square plus b1 square plus c1 square is equal to 4 a1 square b1 square. So now again, this is the same equation as before. We just have a 4 here and different variables. Now again, we know n square is congruent to 0 or 1 mod 4, right? So we can just put it again like case 1. We have a1 square congruent to 1 mod 4. If a1 square is congruent to 1 mod 4, then b1 square plus c1 square congruent to minus 1 mod 4. You can just do it like the previous one I did, and you will get this result. So but this result is not actually possible. This is not actually possible since we are summing up two squares and we are dividing it by 4 and we are getting that is -1. So this is just rejected, and then we have the next case, which is a1 square congruent to 0 mod 4. Then we have b1 square plus c1 square congruent to 0 mod 4. But can you does it look familiar to you? b1 square plus c1 square congruent to 0 mod 4. We got it here. b square plus c square congruent to 0 mod 4. So by this, similarly, we can conclude b1 square is c1, sorry. We can conclude from this a1, b1, c1 all are even. So now again we can put like a1 equal 2a2, b1 equal 2a3, 2b2, c1 equal 2c2. So this just keeps going on, right? So that's why this question is called as infinite descent, because it just keeps going on forever and forever. So we get the final result as an square plus bn square plus cn square equal 4 to the power n square bn square, right? So this we saw, if we put n equal 2, we will get the equation we had here. If we put n equal 1, we will get the original question. So that's why it's called infinite descent. This just keeps going on like infinitely. So now to get to the solution, the integral values of a, b and c, we can see from here that we had an equal to a1 equal to 2a, right? Sorry, I wrote it over. We have a equal to 2a1, so we can write an is equal to a by 2 to the power n. Similarly, bn is equal to b by 2 to the power n. cn is equal to c by 2 to the power n. So this is what we got. Now, to get the solutions, what we have to do is a and b and c n are all integers, since we need to find the integral solutions, and n is very large. So when n is very large, okay, so why n is very large? Since it's going infinitely, the series, we are solving it infinitely, so n is very large. So when n is very large, you can see all of these three quantities tends to 0. All of these tends to 0, right? So what we can write is like, since an, bn, cn, all of this tends to 0, therefore there is only and only one solution: a equals b equals c equals 0. So this was the only solution of our question. Therefore, after solving all of this, the infinite descent has only one solution: 0. A equal b equals c equals 0. So that was the question. I hope you liked it.